I'm gonna start by apologizing for my voice because I was in London last week and I brought back a bug, so hopefully at least it's not transmittable this way, but you might sort of hear some signs from it. Anyway, so my name is Laila. You know where to find me, so I'm just gonna quickly skip this part and start talking about why we're sort of all here. And for my session, that context is observability. Now, I'm guessing that most of you sort of have the context of what that is, or otherwise you wouldn't be in the session, but I still want to take some time to align on what exactly that is. Now, you can sort of think of observability as the ability to understand what's happening in your system. And that refers both to the expected and also the unexpected state that you may arrive to. So, not only thinking of what could possibly go wrong and all of those scenarios, but even the ones that you haven't dared to dream about that would possibly occur in your applications, you should be able to get insight into those as well. Now that should be basically data that's stored outside of your application, so not by querying whatever data store you have or things like that, but literally we're going to use specialized tools to analyze and query information that is stored outside of the system to get more insight into what is happening. And basically the idea is that we can that way get actionable insights. That's the whole goal of observability. It's just not spying for the sake of spying. It's spying with a goal, right? There's no spy that spies with the sake of spying. There's always like an agenda. There's always like something that they want to take out of it, and that's the same for us. We want to get actionable insights on how to, understand our application or our wider system, if you will. Now, there are multiple reasons why we'd want to do that. I think the main reason that got me so interested and so excited about observability was root cause analysis because I work for a company called Particular Software where we built in Service Bus, which is a messaging middleware framework. And I've been using that for years before I joined the company. So I was building message based systems. And one of the things that I struggled with a lot for years was that it becomes a lot harder to troubleshoot these kind of systems because when we observe a specific failure, the odds that the root cause of the failure that we're seeing, that we're perceiving, is happening further upstream, could be 2 or 3 services upstream, and we're just seeing the sort of result of that in a specific service. Another could be, monitoring the health and state of our system, which is extremely challenging in, what we see more microservices architectures or, distributed balls of muds or whatever you're building. But we may want to have we may have some insight into a single thing, but we need to be able to understand how is my whole system doing and are the crucial components up and healthy and things like that. We also might want to get insight into performance of the system. Now, I'm not talking about a single component, right? Especially if we build those distributed systems that have disconnected services that are interacting together, and if we look and connect that back to a sort of larger business process or business transaction, then that usually crosses multiple services. And if you talk to a business expert, they're going to be interested in asking how performant the whole flow is, not an individual service. So that's also a possible reason. We also want to be able to catch any side effects. And remember that not all side effects surface as failures, right? It could be that there's issues that are lingering in the system for quite a while, and they're growing like the virus. I feel them in my body right now. But it's basically like I don't know, things like where you find yourself in a situation of like, hey, this data looks wrong. Oh, this data has been wrong for 2 years and more of that type of data has been growing, right? Those are the types of side effects that I'm talking about in this sort of case. Could also be to sort of get an understanding of user behavior, right? Do your users behave differently across regions, across other types of segments, and get some insight into that. Um, but also, for example, feature flags. Again, the context of this session is these larger distributed systems. And when we're building that kind of system and we have millions of users, then when we build a feature, we're usually not just going to sort of, okay, here's a new feature, go ahead, entire customer base. No, we'll usually, make that available to either people who opt in or maybe like a specific percentage of our user base. And we want to be able to understand how is that feature behaving, are there any issues with that? Is there any increased latency and things like that before we roll it out to the entire sort of user base? But that requires some insight into what's happening in the system. And then finally, chaos engineering, which is an amazingly powerful technique in which we can sort of unleash chaos on a system and try to push it to its limits to see where it breaks. But then we also have to bring back structure to the chaos to be able to understand what is failing, what is struggling, why is this happening? Again, leading to that increased need of observability. So I thought I'd drop like multiple points of angles for you to sort of understand why is observability really important. And I think we find ourselves in a sort of exciting transition period in the industry when it comes to observability because, over the last few years, the industry has been both implementing and adopting the OpenTelemetry project. Now, OpenTelemetry is an open source observability framework. It's led by the Cloud Native Computing Foundation. Actually, their second highest velocity project behind Kubernetes. So it's actually pretty crazy. It's gotten a lot of adoption, a lot of weight behind it, and it's really cool to sort of see that happen. It basically provides a collection of tools, APIs, SDKs, with the goal of enabling teams to standardize how we instrument generate and collect telemetry. You can almost sort of think of it of like a protocol, right? So that whatever backend observability platform you're using, whatever language you're using, that telemetry is going to be instrumented, generated, and collected in the same manner. So I already sort of alluded to that, but it's also interoperable. It's available on multiple languages and platforms: .NET, Java, Rust, Python, Ruby. There's 11. So, I mean, they're available on the website. So there's quite a few. It's has a very wide adoption. Now, the idea is basically, to allow us to track system behavior across multiple languages and platforms. Because again, if we have a super large system, right, and that is based on multiple stacks, which tends to happen, not necessarily because we always choose it that way, but because we're presented with those situations, could be due to mergers or what have you, then we need to be able to understand how our entire system is behaving independent of which language, which platform, which framework, and so forth. And there are three so-called open telemetry signals that you can sort of use to increase the observability of your system: traces, logs, and metrics. Now, I'm going to assume for the context of the session that you sort of know what those are. And what I'm going to try to do is give you some insight into what the goals of the OpenTelemetry project are in terms of those existing signals and how they want to improve those and strengthen those. So we can start with logs, which is basically the oldest type of observability or telemetry that we know. I'm really going to assume that everyone listening has worked in a system application where logs have been available and collected, right? And we've gone through a whole transition of using dedicated libraries and then the logging abstraction from Microsoft with iLogger, and from having it in the event log or on file, and then sort of going to, okay, now let's centralize this. But even so, with all of those sort of improvements that we've made along the way, there are still quite a few problems. One of the biggest one is that there's very weak integration with other observability signals. So if you're using metrics and you're using logs and traces and whatever it was, then um, connecting that all together doesn't really work so seamlessly, right? So that could be due to the use of different collection agents, right? We're using completely different tools. It could also be that there's a mismatch in labeling between logs and also other signals, making it harder to sort of connect that information back together and correlate that back together so that we can understand that these things are connected. But one of the other reasons is that there's no standardized way to include the origin information, the sort of source information. Like we look at a log statement, it's like, where did this come from? Especially if it's like centralized somewhere, then it becomes that part of the story becomes hard. Before we centralized, it was trying to figure out to which machine do I go to find the right logs? And now that we've centralized things, where did this come from? So it's like we're interchanging problems. And that's one of the reasons is that there's no standardized way to handle that concern. And we also lack a sort of standardized propagation mechanism. There's no way to record or propagate anything that is related to the sort of request execution context, right? And that leads to sort of disjoint sets of logs that are collected from different components. And we're still kind of flying blind. And these problems are specifically painful in those larger distributed systems that we're trying to address here. So, what OpenTelemetry does to sort of address these problems is introduce a unified log data model. And the whole idea is that we can have a shared understanding and a shared like agreement of what a log record is and what information should be recorded in there. And then, any existing log formats that are available can then be mapped to this OpenTelemetry model, if you will. Um, and another one is that we'll create or that they will create support for distributed context propagation. So that will also allow us to have the data flow cross service and then be able to further enrich subsequent log records by accessing information that was captured when previous log statements connected to that entire flow were being recorded or emitted, if you will. So we get basically standardized log correlation. And this is going to be based on three different sort of pillars, if you will. It's going to be based on the time of execution on the one hand, but also the execution context. And finally, where did this come from? The telemetry origin. This is all going to be included in that log data model. And that's going to significantly improve, our ability to correlate between logs, sort of different log statements across different services, but also between logs and different signals. So up until now, that was a sort of horrible manual mapping experience. I'm sure all of you can sort of think back to a time where you lost an incredible amount of hours trying to find, the right log file or looking or the right log statements, only to come to the conclusion of, okay, what's being logged here is not actually helpful. But we'll be talking a lot more about that throughout the session. And then next we have metrics. Again, we've been using metrics for years. I'm going to assume you all sort of have an idea of what that is, and focus on what OpenTelemetry sort of brings to the game, if you will. Now, the thing is that OpenTelemetry was based on is a sort of accumulation of the Open Census project and the Open Tracing project, where Open Tracing was focused on distributed tracing, but Open Census was focused on both distributed tracing and metrics. So one of the goals of the Open Telemetry project for metrics is to work well with those existing metric protocols and standards because they were already being used and applied, and including Prometheus, StatsD, and to also provide a migration path for Open Census users. And then again, one of the more, in my opinion, important sort of goals is the ability to correlate the metrics to other signals that we're collecting so that we get that sort of full view of what's happening. And then finally, we have traces. Now, this is the sort of, I guess, newest signal, if you will, in the industry. You can think of it as a sort of relational graph that visualizes an entire business transaction, if you will. It might be part of a business flow, it might be the entire business flow, depending how that's implemented. But the idea is that it is across multiple services, subsystems, network, security boundaries, like, different types of things that take part in that. Could be reading something from the database, sending a message to a queue, doing whatever, heavy calculation you have in there. So you basically get a chain of spans, which include their own individual attributes and events on the span level. And we're going to connect those together. And that connection sort of happens through a correlation ID, which is our trace ID, and that then is propagated through a standardized protocol. Most popular one, W3C trace context for HTTP headers. I hate it every time I have to say that. It's just so long. I struggle with it. Anyway, so the thing is, we have multiple signals, right? Multiple signals that can give us more insight into our system, make us better spies at understanding what's going on inside the system, which immediately raises the question of, well, which one do I then use when, right? And as always, with everything in this industry, the answer is, I wish I was in a live sort of setting where I could hear everyone scream, it depends. Anyway, it depends, right? So what we're rather going to do is sort of look at, the strength and the weaknesses of each so that we can sort of engage in, a trade-off exercise and decide for ourselves what is best. So for metrics, it's really good to do health monitoring to, get a sense of what's going on in the system. It also gives us very good insights into how performant something is, or like, are there, certain things that are happening? Is there something that looks off? And those things are, easily sort of visualized on a dashboard, which then also makes it easy to sort of add alerts so that we can get pings of, hey, this looks off, because nobody's looking at a dashboard the whole day, right? It might be useful that from an alert, you'll go look at the dashboard and see what is off. Now, the important part about metrics is that they're aggregated values, right? They're not independent things. They're sort of put a lot of information together to give you an overall idea of the trend of how something is behaving. But that also means that they carry less context. It's harder to understand, okay, this metric is off, but why is it off? And then for logs, they're, amazing in the sense that anyone can read them. They provide a high amount of detail, but they're really hard to sort of, connect across services. And they also cover a very small scope. I find them especially useful to sort of capture information on sort of startup, shutdown type of scenarios and things like that, especially now that we have so many different observability signals available to choose from. And then finally, we have traces, which is arguably the sort of most powerful observability signal. It provides the deepest insights. It can give you information on performance, how long something is taking, about the flow of events, how things are interacting, in what order things are happening, which can be really crucial in these sort of distributed systems. We'll also get an idea of how is the data progressing? How's that data sort of being modified across services? If this came in into this one, and then it went through service B and C and D, and now the value is that. Why is that so? And that gives you that type of insight. And you get a lot of information. You can capture a lot of the internal state. So you really get like very, very, very deep insights into what's going on. So again, it's really the sort of richest data model that is available. Now, each signal provides value on its own and answers different types of questions. So, in short, metrics will give you insight that something is up in a sort of proactive manner. Hey, go look at this, where the logs and traces can provide insight into the why, how, and where. Now, these are only the technical sort of concerns, and we'll get to other concerns that you have to think of as well throughout the rest of the session. Now, one of the things that I get asked regularly is that, I have a big distributed system. It's quite complex. We haven't really invested in observability at this point, or we've done it really poorly. It's hard to sort of understand, like, where do I begin, right? And basically, the answer, or my answer to that question, is start at the edges of the system, right? Because in today's distributed system, it's escape where multiple services or even services are communicating with each other. I find that those are the sort of main blind spots is how they communicate, how they interact. So I find that a very good place to start. So wherever inter-service communication occur, think of REST APIs, gRPC calls, messages into a broker, etc. And it's also easiest to start there. Why? Because you don't need like a full understanding of how that service works. You don't need to understand all the technicalities and all the business aspects to be able to add instrumentation on the sort of edges of the system. And then based on that, you can see, okay, how much insight does that give me? And then work your way inwards step by step. And the good news is that to instrument at the edges of the system, there's no need for you to make any code changes. Well, hardly any code changes, because the community really has us covered there with instrumentation libraries. Now, there's a bunch of names of frameworks that are appearing on your screen, and I'm guessing that you can recognize at least a few of those to be part of your application. And if you sort of map that to where inter-service communication occurs, then you already see it, right? HTTP, gRPC, ASP.NET, Redis, Azure, AWS SDK. That's how we sort of hand off data from the one service to another. So if we enable these, we already gain a tremendous insight into that inter-service communication, even across infrastructure and everything. And we can really go a long way in understanding what the service behavior is internally. And this is where I really recommend to start, and then adding custom instrumentation from there. So, okay, we might see this and get like super excited and say, okay, then let's collect all of the thing. Let's turn on every instrumentation library on the planet. Well, at least hopefully, those that are connected to the frameworks that you're actually using, at least that. And we're just going to collect all of the traces, all of the logs, and all of the metrics that they emit. And it's going to be great. We're going to have full insight and we'll be good to go. But then before we know it, we'll be confronted with the downsides of doing that, because we're going to be so overwhelmed with all of that data that it's like really drinking from a fire hose. Just, trying to shift through all of that information to get to what's helpful is going to be like its own finding a needle in a haystack. Because what is relevant to a specific scenario, what is not? Does the instrumentation library offer enough insight, or does it, sort of not give me sufficient application specific insight for me to make that actionable? And then how do I make that actionable? So turning everything on is a good first step to get a sense of what telemetry is there. But just doing that and saying, oh, I have an observable system, well, you're not going to be effective at, spying on your system, if you will. Instead, we need to sort of come up with a plan to collect high quality and most importantly, actionable instrumentation that is going to help us move forward. And to do that, I want to take a few steps back because, we're engineers. I'm an engineer for many, many years, and we come at things from the technical angle. But I think to make us really successful, we need to take a few step backs and think in terms of alignment within our team and even within the wider organization. Now, again, observability, we've been talking about this for a few years. You read a lot about it. You see these topics pop up at conferences, but in real life projects, it's still sometimes a rather new topic, right? And that's why we need to make sure that we create alignment. So it's important to understand who is going to benefit from this telemetry data. I remember a project where we were working on, and we had this requirement to build this incredibly sophisticated dashboard of insights and metrics, and we spent weeks on that. Like seriously, it took us weeks to tweak it and get it right. And guess who looked at it? Nobody ever. Like nobody ever. It was just a wasted effort. And for me, that just, is proof that we haven't sufficiently aligned to what was really needed, who was going to use it, in what way was that going to be used. Right? So for me, this is a really important part of the story. We want to be able to understand which signals are going to be used. How are they going to be used? Is there even room to introduce new signals? Because many organizations know logs, they may know metrics, but then distributed tracing, it's like, whoa, Whoa, hold your horses, Lila. That's a whole new thing. And is that going to require me to learn a new tool? And how do I interpret that information? And so ask yourself, who will be looking at that telemetry information? And how do we make sure that it becomes valuable at an organization scale, not an individual service, right? And that's why I think it's really important to sort of invest in what I just sort of came up with as a term, but an observability strategy. So what do I really mean by that? Again, it's about having a clear and shared understanding of what purpose is this telemetry going to serve? Why are you doing this? And it can't be like, "Oh, I watched this cool session by Laila at JetBrains.net days, and it was so cool that," no, not the right reason. It has to come from an actual need in the system that you're building. It could be, because you want to get better at failure investigation, because you want better performance insights, or maybe you came into a project with a massive system and nobody, took the time over the years to document how the system works, and just want to have some insight into system behavior. All valid reasons, but make sure that your reason is valid. And it's also important to have a really clear understanding of the questions that your telemetry should be able to answer at the end of the day. So one of the things that I like to do is to sort of advise to document a set of questions that whatever telemetry you're using, independent of any service you're writing it in, should be able to answer. And these are just a few examples that I'm going to give you, but my point is come up with your own, right? So one of them is how easily can you connect a specific user action to your telemetry, right? If you have a support case and you need that ability to be able to sort of link that back to a specific, to specific insights from in your observability backend, then that's going to affect the type of telemetry that you're going to collect and even the amount. Another question to ask yourself is, what type of behavior do you want to be able to group on? What is going to be interesting for you to look at in the context of the application or the system that you're building, or subsystem most of the times, right? Can you easily identify where the most load is? Again, this is not specifically going to be on an individual service level, but it might be across multiple services. Maybe are you able to debug, something that happens in a production environment based on the telemetry information alone? Maybe this is not a relevant question for again, these are examples. Can you easily find suspicious events throughout the system? Maybe you don't have a full blown like fraud policy built into your application, but you still want to have insight into, I don't know, certain things that might need to give some insight into in that regards as well. So we have to sort of think, how is this telemetry going to be used so that we can improve the quality of the telemetry that we add to our applications as well. Now, all of these questions sort of feed into what I call observability guidelines. And I think it's useful to have this documented, available to the entire team or even across multiple teams, so that that same quality and that same sort of streamlined behavior can be visible from the entire application, independent of individual teams. So also important to understand and to document is which signals are available to us. This may be different per team, it may not be. Which scenarios best fit each individual signal? We might say, oh, for these types of scenarios, we just want to do traces, and for these types of scenarios, we want to do logs. Um, and we also may want to have insight into what types of cases require multiple signals and why is that so? And also having an understanding of where's enough. Remember the early testing days when we finally starting to test our applications, and we were like, we need 100% coverage. Do you really? It, does that mean that your application is now bug free? I think we've learned over the years that that is not the right translation, right? So again, it's about finding that right balance to put yourself into the seat of the people that are going to be looking at that information that is emitted, and try to make decisions based on that, and make sure that you're giving them the right information for them to achieve, their goal, their job, even if that is yourself. I'm talking about a third person, that could be yourself, but you're going to be in a completely different context when you're developing a piece of code than when you are looking at your observability backend trying to understand why something is off. And then finally, there are multiple best practices that should be considered. Again, these should be available to the team, especially because we're still getting better and better at this over time. So we need to ensure that we have that information available, and that we have an understanding of what do we find important within the context of our system, within the context of our team. Now, when it comes to best practices, there are whole books that are written on the subject. So also be on the lookout for extra resources at the end, because I listed the ones that I read and I found useful. But for this session, I sort of made my own selection of best practices that I really wanted to share. So just to underline that this is not a comprehensive list, but it'll give you an idea. Sorry about that. Like I said, I'm still struggling with a cough. So the first one is failure scenarios. Now, I feel that, I don't know, as I gain more experience or I worked in more complex scenarios, like building an individual feature is pretty easy, if you will. It's a lot of the sort of effort and complexity goes in trying to understand what could go wrong. How do we handle those scenarios? Do we handle them at all? Do we just let them occur? And getting insight into that. Now, from the observability perspective, you really want to capture any possible failure scenario that might occur in an application. Again, because you cannot foresee everything that might possibly go wrong. You can't. So, having that captured will at least give you insight into, okay, this happened. Now, let me try to understand why. Those failures then need to be signaled to the observability backend so that we can easily find them there. So we want to include error information, error message, stack trace, inner exceptions, whatever it is, that gives us more insight. We could even consider adding, additional information when a failure occurs. So, especially in the distributed tracing context, you already have that chain, and there's already context being captured at each individual step that is part of the sort of transaction, if you will, business transaction that we are looking at. But still, sometimes you may want to capture some additional information that may otherwise be invisible so that you get more insights into what's going on when you're looking at such a failure. Now, another important part is that our instrumentation should never cause business failure. So we have to be really careful with the instrumentation code that we end up adding. Make sure that keep the complexity low and make sure it's straightforward. Because remember that as valuable as instrumentation is, at the end of the day, it's not a mission critical component, right? If we spend a few weeks, increasing the observability in our system and we release it, and then the whole thing comes down, then it's an absolute failure from the business perspective. So again, this is something that we need to be mindful of. Be careful with that code, because instrumentation code or not, at the end of the day, it's production code, and it should also be tested like any other production code. Now, to make that telemetry insightful, again, events are happening across independent services. We want that information to be connected. And this is not a new concept, right? It's at the basis of how distributed tracing works. It basically works based on that correlation ID that links all of those different spans together and says, this is a child of that, and that led to that, and that led to that, and so forth. And then we get that sort of tree graph of what is going on. But that same idea of context propagation that lies at the basis of distributed tracing could help us improve any signal, not just traces. And that is really the goal of the baggage API. Now, the baggage is a standard to propagate context across services, and it's available for different signals. So that would be, provide you the ability to strengthen any signal that you may be using. Now, a word of care or a very, very strong word of caution here because you have to be careful with how you use the baggage API. It can be powerful. It can also be really, really, really dangerous. There's no other way to say it. First of all, you need to understand that using the baggage API is going to have an impact on your latency because you're just adding information, right? The baggage is either you can use it as a dictionary or at the end of the day, it's just a string. Now, be careful with what you put on there, right? You don't just add in whole collections of stuff because that's going to have an impact on, on, on your latency because you're adding a bunch of information. So you have to be really mindful of how that's affecting the rest of your system. Why is this so important? Because everything you add on the baggage is going to be available on every single hop after it's added, right? So it's really important that you are aware that you are creating impact across multiple services and not just your own. Now, another angle to consider is third-party integration because you have to also become mindful of the third parties that you integrate with. If they have observable systems and they are using baggage, you might be facing a request with a baggage header with a bunch of information that is completely irrelevant to you. Now, you could also turn that around. You're also passing that through to the next party that you then integrate with as well, because that information is just being passed through. So again, this is really to be it's available, it's powerful, but you have to be very well aware of the impact that it has when when you're making use of this API as well. Now, one of the things that is a sort of possible risk when using the baggage API is that you start leaking sensitive information. So I want to talk about that as well briefly. Now, with any type of telemetry that you're using, I don't care which signal it is, it's really important to keep any type of sensitive information out. And even though many of you will be frowning and yeah, I know, but still, like this is this happens so easily. It's such a sort of innocent mistake at the moment in time that it's. I mean, how many times have you just checked in a connection string? It happens, right? We're just people. So be aware that you can have any personally identifiable information in your telemetry. Nothing that ties back to a single individual. Then you get the GDPR request to be removed, and you're like, uh, "Oops." Also, financial, healthcare data, that type of information. Passwords, connection, infrastructure information, anything that would open up a security breach in your system. Now, how do you keep this out? Well, one sort of tool that I refer to a lot are code reviews, because I have a sort of maybe a little bit of a different understanding than many people I've talked to over the years when it comes to code reviews. But I think of it as a sandbox that I have to come back to wearing multiple hats. Because, for example, if someone or I write a feature together with a few colleagues, or someone writes a feature and asks me for a PR review, I will sort of put on my first hat and say, okay, does this feature work as intended? Does it, is it like according to the requirements and all of that? Did we forget any edge cases and things like that? And once I'm like, okay, good to go, then I don't approve the PR. Then it's like for me a mental model of let me put on my testing hat. Have we sufficiently tested this? Have we covered the right scenarios? Are there any sort of um, side effects that we need to test for? Is there enough sort of coverage from the business perspective, not the code perspective? Those are also things that I will consider. And once I'm done, I'll have to put on my third hat and say, okay, let's look at this from the angle of observability and instrumentation. Did we create the right instrumentation? Is this going to give us sufficient insight into what's going on? Are we leaking any sensitive information? Right? So treat those PR reviews seriously. And it's not just like, oh, I scrolled through it, approve. No, that is your opportunity to talk things through and act as a sort of mechanism to ensure that, you're adding quality to an application on all of the levels. But of course, that's not the only way to keep information out. Now, you could also be saying, I'm going to use encryption, or I'm going to tokenize data, I'm going to mask specific data or redact information um, from the instrumentation that I'm emitting from my application. And, you may want to do this in a more sort of centralized manner, and not every time that you log a statement or every time that you create a span, having to think about this over and over again of like, oh, I have this sort of customer object, and there may be some things there that are, you know, not suited to be in the telemetry and having to repeat that code. So that brings me to processors. Now, the thing is that you don't want to go through that exercise every time you create a span, lock something, add a tag, add baggage, whatever it is, right? So you could sort of handle the concerns in a more central manner using these processors. Kind of reminds me of the pipes and filters pattern, for those of you who know that, when data comes in, you transform it, and you pass the result to the sort of next link in the chain, like in a factory, right? The telemetry data is going to sort of flow through that data pipeline, where each individual processor can either further enrich that information, or on the other side, further filter it or redact it, if you will. Now, you can basically define 0 or more processors that do different things, and you can also set up different types of processors per telemetry signal. Again, something to be used with care. Why? Because whatever you're doing in those processors is going to affect every individual signal element that you create. So you're creating a new span, it's going to go through the processor, right? So it's important to be aware of the performancy and latency impact. That is not the right place to query something from I don't know, in REST API or a database or whatever. That has to be like, super fast. So like, you have to be aware that that's going to have a big impact if you do crazy stuff in there. Again, something you can keep an eye out during PR reviews as well. Okay. Um, and that brings me to one of sort of my favorite best practices, and it's also the final one that I will be discussing today, and that is telemetry correlation. Now, again, there are multiple reasons to use different signals to capture insights on a single business transaction. And we've already established that each individual signal does provide a value on its own, right? But imagine that you're working on an existing project, and it includes a REST API, and there are already some, useful log statements in that code. And you've now started to invest in distributed tracing, and you've enabled the instrumentation library for HTTP clients. You're also capturing some metrics to track HTTP request results so that you can alert on sort of a spike in failed requests and things like that. Again, each of these signals, we have the metric, the log, and the traces, they're all, valuable on their own. But we can really boost their value if we can connect all of those together. Because imagine that there's a spike in that failures metric, and you'd be able to figure out which API call that was, and which environment that happened. Because if we sort of can enrich that metric with some kind of correlation information, then we would be able to say, find the related traces. And then we're looking at that tracing information, and because we're still pretty new at this, we still want to be able to connect that back to our logs and then get the picture of what we had in our logs as well. Being able to connect all of that information together is going to make us more effective at understanding what is going on, and that's going to eventually reduce the mean time to resolve. This is basically a metric that is used to understand how long does it take us to resolve an individual incident, right? So it's important to connect our logs and traces through that trace ID and span ID. And alternatively, we can consider capturing the trace ID in metric exemplars. Now, I'm going to explain to you a little bit what this is, but it's really important, or the main thing that I want you to take away from this is that it's really important that we don't, by mistake, introduce what's known as cardinality explosion. So, to sort of give some context on what that is, think of a metric as a value that you can sort of add labels to, if you will, to simplify it, right? That give you more insights. And let's say that you want to collect a metric that represents the failures that occur. You could add a label to that to say, okay, I want to know the status code and I also want to know the environment on which that happened. Now, if you think about the cardinality of this metric, you basically need to look at all of the possible label values for HTTP status code, which is going to be everything under 400 and 500 and whatever, and every possible environment. And the cardinality is going to be every unique combination, every unique possible combination that is available. Now, I hope by looking at this example, you can say, okay, this is fine. But what if I add, I don't know, customer ID in a system like Amazon or something like that, for the sake of the example? That will lead to a ginormous explosion of information. There's a super high amount of data to store, and our bill is going to explode as a result of that. It's also going to become a lot harder to effectively query the information, right? So some observability backends do support high cardinality data, such as Honeycomb, but it's important to understand the sort of limitations of the observability backend that you're using and make sure that you're not doing things that it wasn't built to do. So again, it's about finding a balance. I have a few additional best practices here. This is the time for you to take a screenshot and for me to take a sip of water before we continue. Now, sort of to recap this first part, it's really important to build an observability strategy. And I know this may be like the more boring part and not the exciting code part, but it is a very important ingredient if we want to be effective at it. We have to apply best practices, document case studies, and learn from them. See what we can learn from something that took us a very long time to understand. How can we improve our instrumentation, evaluate the telemetry that we collect, and then we can monitor that mean resolve over time should be going downwards, right? And then we can improve from there. So okay, at this point we could say, well, awesome, we have high quality instrumentation. It's now safe to collect all of the things, right? But then at some point there's a manager in their office and they're looking at a piece of paper like this. Because the thing is that if you're in a high throughput system, even though the telemetry that you're collecting is super useful, it might still be way too costly to collect all of it. So we need to start considering whether we really need all of the data that we're collecting. Now, this applies mostly to traces and logs because metrics are aggregated forms of data. But for this session's context, I will focus on traces for this last part. Now, if we look at all of the traces, right, that are collecting throughout a single system, we'll find that there's probably a whole lot of successful traces. Well, yeah, hopefully. You'll find that there's a small group of errors. Again, hopefully. We'll also find some that are, higher in latency for whatever reason, and we'll find some that have very specific attributes. Now, the thing that you should ask yourself is, do I need all of them to sort of meet my observability codes? Observability goals, not codes. Sorry about that. Or would it be sufficient to say, keep like a sort of, random sample of the successful ones, and then all of the, those that are high in latency and that have errors and have specific attributes that we care about. So it really comes back to understanding, what do you really need? Like, again, what are your goals? What are you trying to achieve? If you want to be able to debug any request in the system, then you need all of it. That's the answer. Then you just, need all of the information you can sample. But if you want to just debug system-wide problems, then maybe you need half. Maybe you just need half of the successful ones, for example. Maybe you just want to understand the baseline behavior of your system, or even less if you just want to understand the system architecture. So again, figure out what you really need. How is this going to be used? And then we can start to talk about, okay, so how do we sample some of that information out? There's two different strategies. There's head sampling and tail-based sampling. Now, For head sampling, the decision to basically keep that trace or not is going to happen at the beginning. So basically, the root span is going to make the decision on whether to keep that trace or not. Now, the default way that this works is a parent-based sampler with a trace ID ratio-based sampler. Lots of complicated names, but the biggest sort of important thing to remember from this is that you get unbiased sampling. It's purely randomized. Now, I do want to point out, remember individual spans are still created, they're not recorded. I have resources at the end that show that this is not a too big deal, but I don't know what types of applications that you're building, right? If performance is an extremely high concern, then this is something to be aware. And next we have tail sampling, where what we're going to do is we're going to collect all of the spans that sort of pertain to a trace, collect all of that, and then defer the decision on whether we want to keep that that trace or not, until the end of the flow, if you will. Now, how are we going to make that decision? Well, usually it's going to be based on the overall trace duration. Is this a high latency one? Or it's going to be based on status, like did any failures occur here? Or it may be based on, specific span attribute values. Be careful with that. That's really a good way to be very biased. But yeah, it's a possibility. And remember that if you're doing tail-based sampling, it's still important to capture a segment of successful traces as well. Otherwise, you don't have a baseline. And we're playing this sort of game of trade-offs again, right? So if we look at head sampling, easy to configure, pretty easy to understand as well. Your non-sample traces, the ones that you are not keeping, they don't affect latency. You get reduced data transmission because you're only collecting and sending stuff through that you're actually going to store. The sampling decision does need to be sort of respected by all services, and this could, depending on how you've set things up and how you've configured it, this might possibly be a challenge. And the biggest sort of drawback of head sampling is that it's impossible to anticipate failures or high latency or other important attributes, which could essentially mean that you're throwing away the traces that you really care about the most. It's just a real risk. Now, with tail sampling, you don't lose those important traces, right? The ones that you care about, assuming that you have configured that correctly, which again is quite a big assumption, especially in that section of other important attributes. But you could sort of say, I can't lose important traces this way. But there's a bigger latency and performance impact because you're collecting all of that information and at the end making a decision on whether to keep it or not. If you then throw it away, then that was sort of in vain, if you will. Another tricky part is that it's not easy to understand when a trace is finished. Like, when is something done? And what if something is failing, halfway through the trace and that's causing delays? Like, at which point do you decide whether a trace is done? You're probably going to have to use some time based cutoff to mark the trace as completed so that you can make your sampling decision, or you could be at risk of waiting forever, right? Now, this is an arbitrary number, so that's possibly going to lead to some gaps in some traces at some point. It's a risk. You still are running into potentially unpredictable costs because you may be saying, I'm only capturing the failed ones. And then there's an Azure outage for 2 hours. And that happens through Black Friday, and you have an e-commerce system, right? That's going to lead to a bunch of failures happening, still creating that spike in your telemetry that you're collecting. Something to be aware of. Also, there's going to be additional pressure on the service that's making the sampling decision, right? Because that's have to gather all of that information and decide, do I keep it or not? And it's tricky to get right because you have so much flexibility. So by definition, it's going to also be tricky to get the balance right. It's definitely something that you have to sort of iterate through a few times before you get that right. Now, in .NET, you can easily set up OpenTelemetry and immediately send all telemetry to an exporter. And this is super useful when you are starting out because you can just turn everything on and send it to the observability backend and start to look at what's there. But it also has a bunch of challenges. because there's going to be an increased load on the individual service that is doing that export. It's also exposing that service to any communication issues with the backend, right? And that could then cause business failures. Important to be aware of that. And there's also no central configuration point. If you have multiple services doing this and you want to change something about that, you're going to have to redeploy all of them. And also no central data management pipeline. Now, to visualize how this would look like, we basically have individual services selecting instrumentation immediately, sending that to the uh, to the observability backend. But there's an alternative, and that's the OpenTelemetry Collector. Now, the goal of the OpenTelemetry Collector is basically to be a sort of mediation layer between your application and your observability backend. It's vendor agnostic, not tied to any individual implementation, and it allows you to receive, process, and export telemetry information. That means you can centralize configuration and management. That means that you can offload all of those risks of handling failures and error scenarios and batching up information to the collector and not doing that in your individual service. And it also allows you to scale per signal. Now, there are multiple deployment options available for the collector. The first one is the sort of sidecar agent option, if you will. In this sort of model, what you're going to do is deploy the OpenTelemetry Collector as a sidecar to the instrumented service, and that offloads the responsibilities of collecting and processing and exporting all of that information to the sidecar away from your service, right? The sidecar can then handle any batching and retries and encryption, compression, whatever concerns that you have, independent of the actual service, but it's at the same time still running on the same node as your service, which means that there's no added latency between the service and the collector itself. It's also going to handle any communication issues. The backend could also hold on to some data while the backend becomes available again, and so forth, right? So clearly, it does also complicate your infrastructure more, but it could be a very good solution to offload individual services. Now, this could look something like this, a sort of more visual representation. So you still have your service sales, but now in the same node, you have that agent that takes care of everything regarding instrumentation. Um, and then that is going to communicate with the observability backend. There's another option to sort of host the OpenTelemetry Collector, and that's the gateway cluster option. In this sort of setup, we're going to set it up as a standalone service, right? And what is going to happen is that all of those services are going to connect with that sort of centralized OpenTelemetry Collector. Makes it easier. It's easier to scale with a load balancer, and this is really required if you're doing tail-based sampling scenarios, because again, you have multiple services partaking in a sort of larger business transaction. You want to sample at the end. So you're going to need this model if you're doing tail-based sampling. Every span that pertains to a trace is going to be need to processed by the same instance, right? It has to be collected in one place so that we can make a decision on all of that data. Again, to translate that into a visual model, we now have a centralized OpenTelemetry Collector that all of the services are connecting to, and that takes care of all of those concerns that we've already talked about. And you could even take this a step further and say, you know what, I'm going to have a sidecar for each individual services, because there are some, for example, the processors are more sort of tightly coupled to the individual service. And because I want to do some processing on that end, and I still have a centralized collector, that is something that you could do. But again, we're further complicating our infrastructure requirements here. And you could even go incredibly crazy and scale out the OpenTelemetry Collector, put a load balancer in between so that you can still make sure that all spans that pertain to a single trace are handled by the same instance. So again, Laila, you're doing this again. I have so many options. Which one do I choose, right? Now, I would say this really depends on the scale of data that you expect. Now, the thing is that the odds are pretty high that you're not Google. or not even, Amazon, Netflix, LinkedIn, whatever it is. So be mindful of how you define scale and don't overdo it from the beginning. Look at what data is coming in, even if that means that you lose some instrumentation for a while. Adjust the scale that you actually have, not for the scale that you think you will at some point have over the rainbow, right? So let's keep things simple, add complexity as you need it, keep things simple as long as you can, learn, iterate, and refine. Okay, and that brings me to the end of this session. So I think if you're serious about observability, you can't really treat it as an afterthought. So it's a matter of time before we talk about observability-driven development. I'm sure you can already Google the term as of now, and find a lot of interesting resources. But I really believe it's important to build and invest in an observability strategy, figure out what do you need, why, how is this going to be used, play the game of trade-offs. What do you need? Like, what are you trying to achieve, and what do you need to achieve those specific goals? If you're still collecting too much information about after tweaking all of that, then you can play the game of looking into sampling strategies and see what's going to sort of help you take control of the amount of data that you have. There's different deployment models that are, available that can align with your individual observability needs, and yeah, help you, you know, effectively spy on your systems. And if you want to learn more, that observability sort of hashtag, it has a name. I don't know what that's called, but what basically happens is that they use the word observability, take the first and the last letters, and they count the letters in between, which are 11 characters, and that led to this sort of acronym, if you will. Could say it's OLLI or observability. Anyway, thank you so much for listening. If you scan the QR code, that will take you to one of my repos where I have plenty of additional resources available. I also have samples available for you to run from another talk, but I'm sure the next talk is going to sort of fill that coding need you have. And I hope this can sort of act as a sort of groundwork to make you successful overall.
Great session, Laila. Great session. And it seems so relevant. We've seen, or at least 2 times, I've seen people in the chat saying, yeah, I blow up my telemetry just because I added too much cardinality and stuff like that. So yeah, also I dropped Martin some questions before, all answered, so I'm happy. We have a couple of questions, including chat. We will try to make it brief in your, so that you don't struggle too much. I think Martin is going to start, yeah?
Yeah, exactly. I just want to add that the poll we ran about what people are using most in their applications shows logs at 65%, traces and metrics at 11 to 13%, and 10% of people using nothing. So I hope they soon start learning about the systems that they are building.
Cool. Well,
onto questions.
Useful then.
Yeah. Onto questions. You mentioned that observability is typically used for failure investigation, performance, and system insights and things like that. Would you recommend using the same infrastructure for getting business insights, like getting a metric on the number of signups or tracing about how someone navigated to the subscription page and essentially made a purchase afterwards? Or would you look at different tools there?
Well, thanks for the tricky question, Martin. No, it's a really good question. I'm actually glad that you asked this. So we have to realize that observability is still aimed at making us successful in running these types of systems, right? Business metrics is a whole other thing. And yes, you could be able, in theory, to detect business type of metrics from your observability backends because you have so much information in there. Now, one of the things that you need to be thinking about is data retention. How long are you going to keep that data in your observability backend? you're not going to have the same needs when it comes to troubleshooting your systems in terms of data retention as the needs that you're going to have around, business metrics. You're probably going to want to hold on to that a lot longer and see those trends across a lot more time. That is one of the sort of biggest ways that makes it a mismatch. So I think it could be good as a maybe starting point, but if you're really serious about business metrics, then you should be looking at different types of solutions for that, in my opinion.
That makes sense. Yep. Thank you.
Next question. Chat was also pointing out there's at least in Serialog there's something like a masking enricher as an attribute. That's going to be interesting to look at. But the question is, any tips on finding and deleting data across multiple sinks? So talking GDPR and stuff like that. Do you have
Yeah.
anything?
Well, if we're talking about GDPR, don't let the data get into your telemetry to begin with. Like, make it
Right.
so that you're never actually going to have to do that, because now you're looking at different observability backends where those concerns are handled differently. And maybe you're not even able to do that. And it's going to mean that you're going to have to throw a bunch of data that you don't actually want to throw out away with that information just to adhere to the GDPR guidelines. So I think in that example, just don't work yourself in such a situation, right? We can still connect that information and have a customer ID, and that's sufficient information for us to link it back to whatever data store that we have. And then we can handle the GDPR concerns in our business databases alone. Um,
Mm.
but I may have given only half an answer now to your question, I realize.
I guess it would still be interesting. Like GDPR was also introduced at some point,
Mhm.
and what if there was a what's the word? I have no idea what the word is.
Legacy.
But
Legacy.
but if there's a new law introduced, then you would have to throw out a bunch of things, something or some themes, any other information as. I mean, I wouldn't think that would happen, but.
Well,
It's something to be philosophical about.
no,
Maybe.
absolutely, absolutely. And we've been bitten by this, right? Which is why we're asking these questions to begin with.
Yeah. Yeah.
Again, I would try to, the information that you expose to your observability backend, it has to be insightful, yes, but it almost never has to be able to sort of connect back to something that it may be even at some point sensitive. So still, I would try to hammer that most of it. But then as part of choosing an observability backend, I would say, when you're making that selection of I want to use, App Insights or this or that, that's something that you need to investigate upfront. If I'm dealing with a situation like this, how do I deal with it? It really ties back to that observability strategy. It's a question that
Mm.
you should have answered upfront and not, oh, now we need to delete it. Oh God, what do I do? It's so I would really recommend when you choose whatever tooling that you're going to use, that is one of the questions that you should be asking your vendor. I can't answer that because it's probably going to be vendor specific, where the data ends up being, how you handle such things. Does that help, Matthias?
Probably. At least me.
Okay.
Cool. Yeah. Speaking of tooling and everything there was one additional question in the chat and a little bit of discussion about whether things worked or not. But I do think it's a great question. And it is, where do you see, or what role do you see for AI in observability systems?
Yep. Well, I think there is a role. I've actually been already seeing, I think recently, posts from Honeycomb, if I'm not mistaken, that they're also starting to fiddle or integrate with AI capabilities so that we can get richer insights, and so that we can even maybe catch things that we haven't set our system up to catch up front, like certain metrics that we haven't thought of that would be interesting to us, but that based on tracing information could be deducted. So I definitely think that having AI capabilities will also allow us to sort of collect even more information and still make us more successful at extracting those actionable sort of insights um, and information. But it will take a while. This is still sort of new, so I'm just looking with you to sort of see how this is going to evolve and enrich that type of space as well.
Cool. Sounds fantastic. I think observability definitely has grown in recent years, and I guess AI and everything around that is also one of those side aspects of observability that still has a lot of room to grow.
Yeah, I agree. Yeah.
All right, great session. We have lots of praise in the chat. Chat also
Thank
confirmed
you.
that answer was helpful, not just to me.
Awesome. And
we-
otherwise, feel free to reach out to me over any of the channels.
Exactly.
Perfect. Thank you, Laila, again for a fantastic talk and
Yeah, thank
for
you.
enlightening us about observability and everything around that.